So here guys, we will discuss today about the Newton-Raphson method. So first of all, we have to know that what is Newton-Raphson method and what can we find by the Newton-Raphson method. So see here that actually this is the procedure to find the root of a algebraic and transcendental equation. So now there is a question that what is transcendental equation and what is the algebraic equation. Actually the transcendental equation is looks like this, that is the x square plus cos x is equal to 0, log x plus 10 sin x is equal to 0, or we can find it more like that is e to the power x plus 2x is equal to 0, and so on. That means that contains the term like e to the power, the functions like e to the power x, tan x, the trigonometric functions, the log functions, and everywhere. Actually, we cannot find the root of this equation by any usual analytic method. And also, when we consider the algebraic equation like x square plus 10x minus 1.06 and x to the power 12 plus 12x, then it is quite impossible to find the root of this equation. So how can we find the roots of the equation? Here we will use the Newton-Raphson method. So what is the Newton-Raphson method? Actually this is a method where we can find the roots of this type of equation. This is an iterative method, and also there is something we have to know here, that is the fact we have to know. That is, if we consider an equation f of x is equal to 0, then we can see that then at least one real root. Real root means this will be maybe positive, it may be positive, it may be negative. So how can you find the root is lying between the interval? That is if f of a into f of b is less than 0. So now the question is that if f of a into f of b greater than 0, then we can say that the root is not lie of that equation or whatever in the interval ab. The root, suppose if we say the root is x, that x doesn't belong to this interval, but it doesn't imply that the equation has no root. It may be somewhere, it may be, namely we can say that root is lying between c and d, whatever. So now here I'm just going to discuss with you that how can we use the Newton-Raphson method. Actually the Newton-Raphson method formula, the working formula is xn plus 1 is equal to xn minus f of xn divided by f dash xn. That means here also we have to remind one thing, the function which we choose, that never, that is the f dash xn is never vanishes. That means f dash xn is always not equal to 0, and f of x is also differentiable. F of x is also differentiable. So now there is a question that how can we solve, or how can we find the roots of any equation, any transcendental equation or algebraic equation we cannot find by any other known method. So here I'm just showing you by one example that how can we find the solution, or how can we find the root of a algebraic equation. We cannot find it by any well-known analytic method. So here I'm just going to consider one equation like this, that is find the root, find the positive root. So here I'm write the question that find the positive root of the equation x square plus 2x minus 2 is equal to 0 using Newton-Raphson method. In short, we can write NR method. So now the question is that how can we solve it? So first of all, here we have to choose the interval. That is, suppose if we consider that let f of x is equal to x square plus 2x minus 12. So here we have to find that the positive real root. That means we can choose that at x is equal to 0. So what is the value of f of 0? That is, we can find it, sorry, this is 2. F of 0 is minus 2, which is less than 0. And if we take x is equal to 1, so f of 1 is 1 plus 2 minus 2. This is 1, which is greater than 0. So now we can say that f of 0 into f of 1 is less than 0. So we can say that here, that one real root lies between 0 and 1. One real root lies between 0 and 1. So in this regard, so now we have to use that, we can say that our initial approximation here we have to take. So initial approximation, that is, we start from here, that is x0 is 0, x0 is 0. But here, that here it is not defined that that from where we have to take the initial value. So here we will just use here one formula, that is, we will try to find the midpoint. What is the midpoint? That is 0 plus 1 by 2, that is 0 0.5. And if we check at the value f of 0 0.5, so what we get at the point f of 0 0.5, that is, this is minus 0 0.75. This is also 0. So now we can also say that since f of 0 0.5 into f of 1 is less than 0, f of 0 0.5 into f of 1 is less than 0. So now again, more comprehensively, we can say that the root lie in the interval 0 0.5 comma 1. So here we can take that x0 is equal to 0 0.5. We can choose it that x0 is equal to 0 0.5. So now here, now if we apply the formula, here if we apply the formula, the xn plus 1 is equal to xn minus f of xn divided by f dash xn. So here if we put n is equal to 0, so what we get from here, x1 is equal to x0 minus f of x0 divided by f dash x0. So what is the value of x0? We will take the value of x0, and here what is the equation we take? F of x is equal to x square plus 2x minus 2. So here you have to calculate f of x0, that is f of 0 0.5, f dash x, that is 2x plus 2. You have to calculate f dash x0, and also, so now from here we can find this is 0 0.5 minus, if we find the f of 0 0.5, it will be minus 0 0.75 minus 0 0.75, and f dash x0 is 3. So now if we calculate it, we will get the value of x1 will be 0 0.75. Okay, so now this is the new one, x1. So now if we put n is equal to 1, we get x2 is equal to x1 minus f of x1 divided by f dash x1. Similarly, we have to put from here everything. That is, if we put that f of x1, we get f of x1 is equal to, that is here f of x1, that means here x1 is equal to 0 0.75, x1 is equal to 0 0.75, and if you put in this equation x1 is equal to 0 0.75, you will get 0 0.75 minus 0 0.0625, and f dash x1 you will get 3.5. So from here you will get the value 0 0.732143. So now here you will get 0 x2 is equal to 0 0.732143. So now if you put n is equal to 2 in this equation, so what you get, that is x3 is equal to x2 minus f of x2 divided by f dash x2. Similarly, you have to put the x2 is equal to this value in this equation and this equation, and I think you will already learn it that how can you find it. This is 0.732143 minus 0.00032. This will be f of x2 if you calculate, and m dash x2 you will get this one is 3.46429, and if you simplify you will get the value 0.732051. So you will get this value here 0.732051. Similarly, now if you put n is equal to 3, so what you get? That is, if you put n is equal to 3 in that equation, you will get x3, sorry, n is equal to 2, that is x3 is equal to, you will get, sorry, n is equal to 3, that means you will get actually x4 is equal to x3 minus f of x3 divided by f dash x3, and if you put all the values you will get 0.732051 minus 0.607 divided by 3.464102, and you will get the result 0.73205. See here that at the, so what you get from here, that is x1 is equal to x1 is equal to 0.75, x2 is equal to 0.732143, x3 is equal to 0.732051, and x4 is equal to, also you find 0.732051. So now see here that these two roots are consecutively repeated, and now from here you can say that these two, that this is the required roots. So that means here this is iterative method, and this is, now we will get after some iteration will, and if you check that you will find also x5 is equal to like this one. So now we can say that the root lies between 0 and 1 of the given equation, is 0.732051. So I hope you understand. So thank you for watching the video.